Hello friends, welcome back to my YouTube channel Journey with Vijay Kumar Shrivastav. Today I am going to present the topic fertilizer sources and forms of nutrients. Before presentation I would like to introduce myself. I am Vijay Kumar Shrivastav. I have done M.Sc Agriculture with a specialization in Agronomy from Pant University of Agriculture and Technology, Pantnagar in 1996. Hope this presentation will be very useful to all of you. So let's move to the presentation. Commercial fertilizers are the major sources of nutrients supplied to the crop. Plants require optimal amount of available nutrients for normal growth. These nutrients can be supplied from various sources, including soil organic matter, native soil minerals, organic materials that are added to the soil by means of compost, farmyard manures and animal manures, atmospheric nitrogen fixations through legumes, and commercial fertilizers. When a soil is not capable of supplying enough nutrients to meet crop and plant requirements, commercial fertilizers can be added to supply the needed nutrients. There are numerous types of fertilizers that can be used to supply primary, secondary as well as micronutrients. All fertilizers are labeled as nitrogen percent, P2O5 phosphorus percent and K2O potash percentage on dry weight basis. For example, if a fertilizer is labeled as a 15-5-10, it means that the product contains 15% nitrogen, 5% P2O5 and 10% K2O by weight basis. First we will study about nitrogen fertilizers. Nitrogen fertilizers refer to one of the most common categories of fertilizers produced out of nitrogen chemical combinations. Inorganic nitrogen fertilizers are produced by mixing nitrogen from the atmosphere. Natural gas is used as the energy source and is a major component of the cost of nitrogen fertilizers. Now we will study about different types of nitrogenous fertilizers. First one is urea. Urea is one of the important nitrogenous fertilizers which is used on large scale for the supply of nitrogen nutrients to the crop. It is having 46% of nitrogen content. Urea is soluble and readily available source of nitrogen. Urea is produced by reacting ammonia with carbon dioxide under pressure and at elevated temperature. So after reaction of ammonia with carbon dioxide under high temperature, it will result as urea production. Urea contains the highest percentage of nitrogen of all dry fertilizers. Urea comes under dry fertilizer category. Placing in too much contact with germinating seedlings means very close to the seeds and seedlings can kill seedlings and damage seeds due to ammonia release. Urea is very susceptible to volatilization losses due to rapid hydrolysis of ammonium carbonate can cause significant nitrogen losses as ammonia gas. When urea is applied to the surface of soil and is not incorporated into the soil properly. In case of volatilization, the urea having the reaction in presence of water and it will form ammonia gas if it is in direct exposure to the sunlight, and it will cause loss to the nitrogen. Rainfall or irrigation up to 0.5 inches or more will prevent ammonia volatilization losses. Second nitrogenous fertilizer is ammonium nitrate. It is having the nitrogen content of 34%. It is also soluble and readily available source of nitrogen. It comes under dry fertilizer product category. Ammonium nitrate contains 50% of the nitrogen in forms of ammonium and 50% of the nitrogen is present as nitrate, which is the form susceptible to leaching and denitrification losses. Ammonia volatilization is not an issue in case of ammonium nitrate unless it is applied to the high pH soils having pH of more than 7.5. Ammonium nitrate is having the nature of a strong oxidizer that can react violently with other incompatible materials. So if we are going to mixing with other fertilizers, it should be compatible, otherwise it can cause the damage to the crop because of reactions. Ammonium nitrate should be stored properly to prevent risk of explosion. Natural affinity to absorb moisture limits bulk storage during summer, because ammonium nitrate having the nature of absorbing the moisture from the atmosphere. Next nitrogenous fertilizer is ammonium sulfate. Ammonium sulfate contains 21% of nitrogen and additionally 24% of sulfur content. It is also soluble, readily available source of nitrogen and sulfur. This also comes under dry fertilizer product category. Ammonia volatilization is not an issue unless it is applied to high pH soils having pH more than 7.5. It is also marketed in a liquid form where it is containing 8% of nitrogen and 9% of sulfur content. Next nitrogenous fertilizer is sulfur-coated urea, where the nitrogen content usually ranges from 30 to 40%, and it is having the nature of slow release form of nitrogen, and urea fertilizer granule is coated with elemental sulfur, and nitrogen release is dependent on breakdown of sulfur coating. Next fertilizer is polymer coated urea, where the nitrogen content varies with the product. It is also having the nature of slow release form of nitrogen. Release rate of nitrogen depends on the product and is influenced mainly by temperature controlled breakdown of the polymer coating. Release rate of nitrogen is more precise than most slow release products, and it is often more expensive than other forms of nitrogen fertilizers available in the market. Next fertilizer is ammonium thiosulfate. It is having the nitrogen content of 12% and additionally it is having the 26% sulfur. It is a readily available source of nitrogen and sulfur, and this fertilizer is liquid form of fertilizer. It can inhibit germination if placed too close to germinating seeds. So while the application, this fertilizer should be placed on a sufficient distance from the seeds and seedlings. Other nitrogenous fertilizer is Aqua Ammonia, which is having the nitrogen content of 20%, which is most commonly available content in this fertilizer. It is produced by dissolving ammonia gas in water, and it comes under liquid fertilizer category product, and it is susceptible to ammonia losses, and it must be injected into the soil to prevent ammonia losses. Next nitrogenous fertilizer is Anhydrous ammonia. It is having the nitrogen content of 82%, and this is the fertilizer with the highest analysis of nitrogen, and it is injected into the soil as a gas. Losses during application can occur if not applied properly. Losses are more prevalent when soils are too dry or too wet during application. So the soil conditions should be in mid-level where the moisture content and dryness aeration should be proper. And these fertilizers to be stored as a liquid under pressure, because we have to take the extreme caution during handling, because it is having the accidental natures and it can cause severe burning of skin, lungs and eyes. Next fertilizer is non-pressure nitrogen solutions. These fertilizers contain the nitrogen 28% to 32%, and it is soluble and also readily available source of nitrogen. It also comes under liquid fertilizer product category, and it is easy to store, and this fertilizer is usually referred as urea and ammonium nitrate, because it is prepared by dissolving urea and ammonium nitrate in water. And this fertilizer also works as herbicide carrier, and ammonia volatilization losses is an issue for the urea portions of this fertilizer when it is prepared through urea dissolving in water. Other nitrogenous sources fertilizers are isobutylidine diurea and urea formaldehydes. First we will study about isobutylidene urea. Nitrogen content usually at least 30%, and it is also slow release form of nitrogen, and these products are a mixture of urea and isobutylaldehyde, and nitrogen release is primarily driven by hydrolysis, which is accelerated by the low soil pH and high temperature. Now second is urea formaldehydes, where the nitrogen content usually varies from 35 to 40%, and this is also slow release form of nitrogen, and these are the products mixture of urea and formaldehyde. Nitrogen release is primarily driven by microbial decomposition. Environmental conditions influence nitrogen release by impacting microbial activity. Urea forms usually contain more than 60% of nitrogen is insoluble because they contain relatively long chained molecules, while methylene urea usually contain 25 to 60% of nitrogen is insoluble and contain relatively medium chained length molecules. Next fertilizer category is phosphorus fertilizers. The basic ingredients for producing phosphorus fertilizer is rock phosphate. Most rock phosphates come from the mineral apatite, a calcium phosphate minerals that is mined out of the ground. Most conventional phosphorus fertilizers are made by reacting rock phosphate with sulfuric acid to produce phosphoric acid. The phosphoric acid is then further processed to create many of the more common phosphorus fertilizers. First important phosphorus fertilizer is Diammonium Phosphate, which is also known as DAP. It contains phosphorus of 46% and additionally having the nitrogen content also 18%. This is soluble and readily available source of phosphorus and nitrogen, and this fertilizer comes under dry fertilizer product category. Initial soil reaction can produce free ammonia, which can cause seedling injury if too much fertilizer is placed near the seed, and this is a acid forming fertilizer and mostly used phosphorus supplying fertilizer content. Second is Monoammonium Phosphate, which is called as MAP. It is having the phosphorus content of 52% and additionally nitrogen of 11%. This is soluble and readily available source of phosphorus and nitrogen, and this fertilizer also comes under dry fertilizer product and acid forming fertilizers. Next phosphorus fertilizer is concentrated superphosphate. It contains the phosphorus content of 46%, and this is soluble and readily available source of phosphorus. This fertilizer comes under dry fertilizer product category, and this is also known as triple superphosphate or treble superphosphate. Other phosphorus fertilizer is ammonium phosphate. It is having the two types of nutrient combinations. First combination contains 34% of phosphorus along with 10% nitrogen, and second combination contains 37% of phosphorus along with 11% nitrogen. This fertilizer is also soluble and readily available source of phosphorus and nitrogen, and this phosphorus comes under liquid fertilizer product category, and this is popular source for starter fertilizers and good fertilizer source for mixing and applying with micronutrients. Now to study about potash fertilizers. First one is potassium chloride, that is oftenly known as MOP, muriate of potash, and this is most abundantly used form of potassium fertilizer, and it contains 60% of potassium in form of K2O, and this is water soluble source of potassium. Other source of potassium fertilizers are potassium sulfate. It contains 50 to 53% of potassium along with 18% of sulfur and 2.5% of chlorine, and this is majorly used for chloride sensitive crops. And next is potassium magnesium sulfate. This contains about 22% of potassium, 11% of magnesium, 22% of sulfur and 2.5% of chlorine. Along with potassium, this product is a good source of magnesium, sulfur, and this is often referred as sulfur potassium magnesium or potassium magnesium K-Mag fertilizer, and this is water soluble source of nutrients. Other potassic fertilizer is potassium nitrate KNO3, which contains about 44% of potassium in form of K2O and 13% of nitrogen, and all nitrogen is present in form of nitrate form. Next category of fertilizers is sulfur fertilizers. Sulfur is sometimes applied when other fertilizer sources are applied. For example, when ammonium sulfate is applied to supply nitrogen to the crop, plant available sulfur is also applied at the same time. Sulfur is taken up by plants is the form of sulfate ion. So most fertilizers that are applied in the sulfate form will be immediately available for root uptake by plants. Gypsum calcium sulfate is less water soluble than the other sulfate fertilizers, but it can be effective and efficient source of sulfur as well as calcium also. Sulfur is applied in a form other than sulfate, such as elemental sulfur, must be oxidized by sulfur oxidizing bacteria in the soil before the soil sulfur can be taken up by the plants. The oxidation of elemental sulfur to sulfate creates acidity, so elemental sulfur can be used as an amendment to reduce soil pH. Elemental sulfur is quite insoluble, so it will take several weeks to reduce soil pH and it gets available to the plants. There are some factors which will influence the rate of oxidation of elemental sulfur and its availability to the crops like temperature, moisture, aeration and particle size of the fertilizer granules. Here we have shown the list of fertilizers which contain sulfur, like elemental sulfur, which is having the 100% of sulfur content. Second is ammonium bisulfate, which contains 17% of sulfur. Then ammonium polysulfite, which is having 40 to 50% sulfur content. Then aluminium sulfate contains 14% of sulfur. Ammonium sulfate, which contains 24% of sulfur. Then ammonium thiosulfate, which is having the 26% of sulfur content. Then gypsum, which contains 18.6% of sulfur. Then K-Mag potassium magnesium content, which contains 22% of sulfur, and potassium sulfate having 18% of sulfur content, and magnesium sulfate, which contain 13% of sulfur. So these are the different fertilizers which are used as a source of sulfur. Next fertilizer category is calcium fertilizers. Calcium is a nutrient that is present in soil in relatively large amounts. Most soil that are deficient in calcium are acidic, so a good liming program will usually provide adequate calcium to meet most plant needs. Gypsum calcium sulfate can be a good source of calcium in the unusual situation that calcium is needed, but lime is not needed to increase soil pH. Here we have listed out some calcium fertilizers which are the good source of calcium, like calcitic limestone, which contains 32% of calcium. Then dolomitic limestone having 22% of calcium content. Then hydrated lime having 45% of calcium. Then calcium oxide having 55% of calcium content. Then gypsum having 22.3% of calcium. Calcium nitrate, which contains 9.4% calcium, and basic slag having 29% of calcium content. So these are the sources of calcium supply to the crop. Now we will study about other fertilizer category, magnesium fertilizers. The most common fertilizer source of magnesium is dolomitic limestone. When a soil shows tests that lime is needed to raise the soil pH and soil magnesium concentrations are low to marginal, in such cases we have to apply dolomitic limestone to raise soil pH and add magnesium to the soil. Limestone has a low solubility and break down slowly in soils. Therefore, if a quick response to magnesium is needed, a more soluble source of magnesium fertilizer should be considered as a Epsom salts. Here we have listed out different sources of magnesium and the fertilizers which are like dolomitic limestone having the 3 to 12% magnesium content, Epsom salt which is having the 9.6%, cassiterite having the content of 18.3% of magnesium, then K-Mag having 11% of magnesium, magnesium nitrate 19% of magnesium, magnesia having 55 to 60% content of magnesium, and basic slag having 3% of magnesium. So these are the fertilizers by which we can supply the magnesium to the crops. Now turn to study micronutrient fertilizers. There are many different fertilizers that are marketed as micronutrients which are needed to the crop in a very small amount. Usually micronutrients are mixed with fertilizers containing nitrogen, phosphorus or potassium. Because there are so many brands of micronutrients, it is important to read the label to determine the source of the micronutrients in the fertilizers. There are three primary classes of micronutrient sources, like first one is inorganic sources, second is synthetic chelates, and third natural organic complexes. Because micronutrients are needed in such small amounts, the best method to correct a micronutrient deficiency is usually by application of the micronutrients through foliar fertilization. It is important to remember that there is a strong relationship between micronutrient availability and soil pH. Therefore, micronutrient availability can be maximized by keeping the soil pH in the correct range. So this presentation was all about fertilizer sources and forms of nutrients. Hope this presentation will be very useful to all of you. Now my presentation ends here. Thank you very much. I have given here my YouTube channel details, Journey with Vijay Kumar Shrivastav. Having request, please visit the channel, subscribe it and provide your kind and valuable feedback for further improvements. Thank you.